Hey guys. For my virtual learners, hope you're having a great start to your week. I just wanted to make sure that you got to see kind of what we were reviewing today. I'm hopefully going to be able to put up a picture or at least write out the pattern chart that we started in this class as far as some proofs and patterns that we see sometimes with those. So be on the lookout. I should have that uploaded today on Monday. And so for actual class, I thought we would kind of hop around a couple days here. Really, day 10 doesn't have much of what we need for right now, especially on this test and this chapter. But what I did want to look at was page 2 of day 10. There is a theorem, or a property, I'm sorry, a set of proofs right down here that we need to do. And I thought this would be a great chance for you guys to practice what we've been talking about. So they give us that angle 3 is going to be equal to angle 4. We're told that. But more importantly, I want us to think about what topic is being covered here. Look at this picture. Don't we have, what are these angles right here? We have 3 and 1, and we have 2 and 4. Aren't those vertical angles? Yeah. And so, guys, that means usually when we have vertical angles, and we're going to use that, that usually means there are 3 things that come into play here. That means we're going to have vertical angles, so we're going to have the definition, which will lead to the theorem, which usually will lead to the transitive property. And let's look at what I mean here. Take a look. And if you want to pause the video, you can pause if you want to practice this one. Okay, so definition to theorem to transitive property. Let's see if that works out here. So we're given 3 equals 4. Well, but also, don't we see here, let me zoom out a little bit. Don't we see here that we have 3 and 1 and 4 and 2? Those are going to be 3 and 1 and 4 and 2 are vertical angles. And if we're talking words here and just that these are vertical angles, that's going to be straight up based off the definition of vertical angles. Straight up. Now, based off these being vertical angles, what can we then say? That's right. We can say that angle 3 is going to equal angle 1, and angle 4 is going to equal angle 2. And that's thanks to our theorem. We got the vertical angle theorem. That's going to let us say that. Excellent. Well now, if 3 equals 4, and we know we have 3 and 4 here, if 3 equals 1, 3 equals 4, and 4 equals 2, then we can say, oh, cut out the middlemen, then 1 is going to be able to equal 2. Thanks to my favorite property, transitive. So take a second, guys, look back over this. See what you think. See if that makes sense. Now, on to our last day of the chapter. Last day, and we're talking straight chapter review. And speaking of review, the very first thing that this first page covers, it covers day 1. So what I would like you guys to do now is go back to day 1. And if we're told that if you are a quarterback, then you play football. If that's our conditional statement, I want you guys to give me 3 things. Give me what the converse of that is, what the inverse of that is, and what the contrapositive of that is. And then make sure you state whether each statement is true or false. So write out these 3 and then just put a T for true or an F for false. And as you're working, or if you didn't pause the video, I wanted to just give you another chance, just a hint here, about what these 3 things mean. If you need a simpler way to look at it. So go ahead, guys, finish up here on these 3. All right, check it out here. Converse, if you play football, then you are a QB. So we flip the hypothesis and conclusion. Now, if you play football, then you are a QB. That is false. There are plenty of other positions besides QB. How about this one? If you aren't a QB, then you don't play football. Now, some stuck-up QBs might think that. I don't think our QB thinks that. But yeah, if you aren't a QB, then you don't play football. That's just not true. Once again, there are plenty of positions in football. How about this one? If you don't play football, then you aren't a QB. So if we don't play football, then yeah, that'd be right. We aren't going to be a QB because we're not going to be anything. That's true. And so we said that up here, if you are a quarterback, then you play football. That's a true statement. So on number 4, we said that's true just now. If it is true, we know the contrapositive is also true. That's going to be the logical equivalent. They're pretty much saying the same thing here. And so we know that the contrapositive and our original are the only two that are true in this case. So on to, we're going to skip just a page and jump over to page number 3 on day 11. Now, we've got 2 proofs here. And I'll give you a heads up. Number 9 is only going to be a 4-step proof. Number 10 is going to be around a 7-step proof. So I want to apologize ahead of time. I didn't give you a lot of space here. So I would recommend writing pretty small if you can. Maybe something like that, if that's all right. But up here on number 9, I think you will only need, believe you only need 4. So you can space those out a little bit, right? And so, once again, when we deal with proofs, the important thing is look at the topic. Look at what they give you. Angle 5 equals angle 6. And then look at the picture. And wait a minute. Don't we have some vertical angles here? Yeah, we know 5 is going to equal 6 based off what they give us. Now, 5 and 6 are not vertical angles. But I think 5 and 7 are going to be vertical angles. So I'm going to get just the ball rolling for you guys, and I'm going to let you take over. So 5 equals 6, that is given. And then I want you to be reminded of, remember back on day 10? Definition leads to theorem, leads to the transitive property. More times than not when you're talking vertical angles. And so I will let you guys see. If you can pause the video now and see what you do on these last 3 steps. Okay, so 5 and 7 are vertical angles based off the definition, non-adjacent, right above each other using the same lines. And if they are vertical angles, we know they're going to be congruent, and we can justify that thanks to the theorem. And check out this repetition. If 5 equals 6 and 5 equals 7, we can say angle 6 equals angle 7, thanks to my favorite property, the transitive property. And then let's finish strong here, guys. Number 10. Once again, we've got ourselves some vertical angles. Now, they don't tell us that. And we're also going to have to be a little bit more creative with what we need to prove. Check it out. Instead of saying this angle equals that angle, we're trying to say angle 3, so this angle is really 92. That means this is going to be some algebra. We got some algebra going on, and if algebra is going on, that means we've got also substitution. There's going to be some substitution going on along as well as vertical angles kind of going on here. So let's start with what they give us. Angle 3 equals 3x plus 14. Angle 4 equals 5x minus 38. And that's just straight up given. Now, we can tell these are going to be vertical angles. So 3 and 4 are vertical. And again, that is the straight up definition of vertical angles. And I forgot to write the 4. And if they are vertical, we know that means they're going to be congruent. Thanks to, you guys are probably catching on to this pattern, thanks to the vertical angle theorem. Now, the problem is we can't necessarily say that the transitive property is going to come in here and just give us our answer, because we're not trying to prove that angle 3 equals some other random angle 5. Instead, we're trying to say, hey, we got to find out what angle 3 is. Well, if 3 equals 4, don't we kind of know what these angles are? 3x plus 14, 5x minus 38. I'm thinking we can plug in for 3, 3x plus 14 equals, we can plug in for 4, 5x minus 38. And now I'm thinking we can start to combine like terms here a little bit, guys. So let's, we can do some, I'll try and kind of combine this. We will CLT it. So I'm going to subtract the 3x over. That gives us, and I will add the 38 over. We'll do it this way. Subtract the 3x over. Okay. Swing that over, add that over. You end up with 52 equals 2x. Oh, and I'm sorry. We didn't use CLT on step 4. How did we replace 3 and 4? My bad. We used substitution. Yep. And so from here, remember how we said substitution to algebra? That's where this is going to come in. My fault, guys. So then step 5, how do we get 52 equals 2x? Well, we subtracted the 3x over. We added the 38 over. We used CLT. My fault on that one. CTL. What am I? I'm on a roll. CLT. We combine like terms here. Now, how are we going to solve for x? Well, looks like we need to divide by 2. So x is going to equal, looks like 26 using division. Then we plug 26 back in up here, and we work that out, and I believe we can say angle 3 is going to equal 92. And we can say that thanks to which property lets us plug a number back in and solve? Well, I'm thinking substitution one more time. So sorry about these couple miswrites here, guys. That's my bad. And that'll be it as far as day 1 review. I'm going to post some extra review tonight over just some extra practice. Also, please make sure that you do our day 9 page 4 homework form that's been posted. And I'm going to have, again, extra practice tonight. So extra practice will be posted tonight. These are 2 separate things. All right. Thank you, guys. I'll be talking to you soon.